This video will cover the homework problems from section 3.1, and it is called functions. With this assignment, we're going to look at domain, range, and to decide if something is function or not. First question is, state the domain and range for the following relation. Then determine whether the relation represents a function. So in math, domain means set of x values. So for domain, we're going to look at the x values for each ordered pair. The domain from the first ordered pair, it will come as 5. From the next ordered pair, -1 is in the domain, 7 is in the domain, and 5 is in the domain. Again, domain means set of x values. Now for range, range means set of y values from the ordered pairs. So from the first point, the y value is 2. From the second point, the y value is again 2, but I don't have to write it. Y value is 4 from the third point, and then the y value is 18 from the last point. And there are 3 numbers in the range and 4 numbers in the domain. Does this relation represent a function? In order to decide this, if the same x value is not trying to pair up with different y values, we will say, yes, it is a function. So when I look at these x values, they're all different x values. So we're going to say, yes, it is a function because there are no ordered pairs with the same first element and different second elements. This is how we decide if something is a function. It's a function because no same x value is trying to attach with different y values. For the second question here, state the domain and range for the following relation. Then determine whether the relation represents a function. Again, we're going to find the domain and range, and we will decide if this is a function. Domain means the set of x values. So the x value from the first one is -3. X value from the other one is again -3, but I don't have to write it. Next x value I see is 0. And then the last x value I see here is 5. So these are the domain numbers for this relation. Range values will be obtained from the y values. So the first y value is 3. Next y value is 6. Next y value is 1. And final y value is 0. What we noticed here is from the first and the second order pair, they have the same x value. They both have this. So this is domain, and then this is range. So they both have a -3, but for the first ordered pair, -3 is trying to go to the +3, but for the second ordered pair, -3 is trying to go to 6. A human being cannot be in 2 different locations at the same time, so this is wrong. This means this is not a function because the same x value is trying to go to 2 different y values. So we're going to choose the no function option because -3 as the first element is trying to pair with different second elements. So we're going to choose C as the correct answer for this. For third question, it's asking for the domain of this function. So domain for functions will change from function family to function family. So what I see is here a rational function. Rational functions are defined for x values except denominator cannot be a 0. So for rational functions, and any function looks like a fraction, it is a rational function. Rational functions cannot have a 0 in their denominator. This is the rule. So whatever the number makes the denominator equal to a 0, that number must be excluded from the domain. So the denominator here, x plus 45, when I set this to a 0, I can find out what number makes it a 0. So if you solve this very simple linear equation, whenever x is -45, -45 plus 45 gives me a 0 in the denominator, which is a problem. So -45 must be excluded from the domain. Every other number is good to use, but only -45 will be excluded from the domain. So we're going to choose the answer is The domain is all the x values, so this is called set builder notation. We can use any x we like, except x shouldn't be equal to a negative 45. So this is the sign here, x cannot be equal to a negative 45. This is the only problem number for number 3 for this function. For question 4, now we have a linear equation and we want to find the domain for linear equation. For any linear function, they don't exclude any numbers from their domain. Their domain function is always all real numbers, which we can say any number from negative infinity to positive infinity is good to use. They do not exclude any numbers. So type your answer in interval notation. We're going to tell them that for all linear functions, domain is from negative infinity to positive infinity, nothing to exclude. They get along with any number in the number system. Next question, we want to find the domain for this another rational function whose denominator is equal to x squared minus 196. So I need to find the domain for this rational function. It is a rational function because it still looks like a fraction. So we know that the rule is denominator cannot be equal to a 0. So first thing is, what number makes the denominator equal to a 0? So I'm going to figure out the problem numbers. So I can add 196 to both sides. And then because this is x squared, x will be equal to plus and minus square root of 196. And then this will be equal to a plus and minus 14. So whenever x is 14 or negative 14, the denominator is equal to 0. If I show you my answer on a number line, negative 14 should not be used in the domain, so this is a bad number to use. And positive 14 should not be used in the domain. This is a bad number because these two numbers make your function undefined by giving a 0 in the denominator. But everything else is good to use. Now, this means I can use anything from, remember, this is always your negative infinity and this is always your positive infinity. So any number is good to use from here to all the way to negative 14. You will stop when you reach the negative 14. And then you will hop over negative 14. You can use any number from negative 14 to positive 14, but don't use this. When you arrive to this number, just skip this number. And then again, you can use any number after 14. So now when I put this answer in an interval notation, I am going to try to fit here. I will tell them that I can use any numbers from negative infinity to negative 14, but do not use negative 14. Again, you can use any number from negative 14 to positive 14, but don't use any of these, so they have the open parentheses. And then union, the last interval you can choose your numbers from is 14 to infinity. And this is how we are going to answer number 5. The last question on this assignment is domain for a square root functions. So for square root functions, I want to just find their most simple parent function. Most simple parent function is square root of x. And the rule for domain is whatever you have under the radical, and in this case we have x, the rule is x must be always greater than or equal to 0. This is the domain rule. Whatever you're taking the square root of, that must be greater than or equal to 0. So for number 6, what we have under the radical is 2x minus 16. According to the rules, this expression must be greater than or equal to 0. So I need to solve this inequality for x. So we will add 16 to both sides. So 2x must be greater than or equal to 16. Then divide both sides by 2. So x must be greater than or equal to 8. So this is the rule for domain. I can use any numbers from 8 to infinity. And they want the answer in interval notation. So that means I can use 8 because 8 gives me a 0, and I can take the square root of 8. That's still defined. And any number after 8 is good to use. And this is how I am going to find the domain for number 6. This concludes 3.1 for functions.